Now we will continue. Now the periodic trend in the metallic character of element is clearly understood from their position in the modern periodic table. Let us first consider the metallic character of elements belonging to the same group. So already we know that in the periodic table groups are there and the periods are there. So while going down a group, a new shell gets added. As already we have seen in the case of first group, the new shells are get added. Okay, so we have seen in lithium, you see 1 and 2 shells are there. Then after that in sodium, 3 shells are there, 1, 2, 3. So get added, resulting in an increase in the distance between the nucleus and the valence electron. So as we know that the distance is increasing, because as the shells are increasing, the distance from the nucleus and the valence electrons are increasing. So this results in lowering the effective nuclear charge and thereby lowering the attractive force on the valence electrons. So as the shells are increasing, there is a decrease in the nuclear charge. Okay, so the pull is very less towards the nucleus. As a result of this, the tendency of the atom to lose the electron increases. Okay, the lose electron increases because there is no pull, so increases the electrons are. There is a tendency of the atom to lose the electron because no attraction is there, so electrons are easily taken. Okay, so that is the specialty of the atom metals also. They give the electron. Also, the penultimate shell becomes the outermost shell on losing valence electron. Now, what is penultimate shell? For example, you see here, we know that in sodium case, it is having the 11 electron. Okay, so 2 here, 8 in this second shell, and the third 1 is in the third shell. So, for example, if it in the sodium chloride combination, if it is this electron is taken, okay, so what happens? So this shell becomes the outermost shell now. Okay, first this shell was the outermost when the electron was there. When after it is shifted to or transferred to the chlorine, so this shell becomes the outermost shell. Such type of shells are called as the penultimate shell. Understood? No? Okay. So the penultimate shell is a complete octet. Okay, so therefore the resulting cation has a special ability. Due to this, the tendency of the atom to lose electrons increases further. So the metallic character of an atom is its tendency to lose electron. Therefore, the following trend is observed. The metallic character of elements increases while going down the group. So metallic character of elements goes on increasing. Already we have seen when the metals are giving the electrons, so it is increasing. Now while going from left to right, where in period or within the period, the outermost shell remains the same. Now consider now this one. This I have taken the second period. Okay, the first member of the second period is lithium, beryllium, then boron, then carbon, then nitrogen onwards. Okay, so what they are telling now, how here while going from left to right within a period, the outermost shell remains the same. So you see here only here electrons are increasing here. You see in this case, this is 2 shells it is having. Second period means 2 shells. So 1 electron is there. Again here what happened in beryllium case, 2 electrons are there. So the electrons are increasing, but the shells are not increasing. Okay, and hence the attractive force is increasing here. The pull is increasing of the electrons. Okay, electrons are pulled because electrons are increasing in the same shell. So how the positive charge of the nucleus goes on increasing while the atomic radius goes on decreasing. Okay, so radius is decreasing, atomic radius. Okay, and thus the effective nuclear charge goes on increasing. As a result of this tendency of atom to lose valence electron decreases. Okay, within a period from left to right. So here no, as we know that the radius is not increasing. Okay, the radius is same, but the electrons are increasing, and what is happening? The pull of the nucleus, it is pulling the electrons. So there is very less chances to take out the electron from here because the attractive pull of the nucleus is increasing from left to right. The two factors, namely the increasing nuclear charge and decreasing atomic radius as we go from left to right within a period, are responsible for increasing the effective nuclear charge. Therefore, the valence electrons are held with greater and greater attractive force. This is called electronegativity of an atom. So in the non-metal, electronegativity is there, and in metal we have seen already electropositivity is there. You got my point? Electropositive means giving the electrons, and electronegative means taking the electrons. Due to the increasing electronegativity from left to right within a period, the ability of an atom to become anion by accepting outside electrons goes on increasing. The tendency of an element to form anion or the electronegativity is the non-metallic character of an element. Okay, then our last topic, last point in this chapter, gradation in halogen family. So halogen, actually the elements which are in the group 17, they are called halogens. So the group 17 contain the members of the halogen family. All of them have the general formula X2. What is X2? Actually generally this in the halogens, for example fluorine, chlorine are gases, so they are called as halogens, and they appear to be in the diatomic form, F2, Cl2, Br2 and iodine. Okay, so a gradation is observed in the physical state down the group. Thus the fluorine, chlorine, bromine, these are the fluorine and chlorine are gases, bromine is a liquid while iodine is a solid. So by this we have completed this chapter second also. So you will write the question answer from the exercise by yourself. Okay, thank you.